Hello there, welcome back to my workshop. Today we're looking at a new retro style computer kit. It's called the Pico computer, and as you might have guessed, it has two Raspberry Pi Picos on there. So the computer is actually based on a new 6502 with modern RAM, but it uses one Pico for graphics and one Pico for all of the inputs and outputs, like talking to a keyboard and peripherals. So in this video, we're actually going to build the kit from scratch. I sourced the circuit boards and all the parts myself. You can actually buy them. They're assembled by PCBWay. I'll link in the description to the original video by Rumblethumps if you want to take a look at his video. He's the guy that created this, so I do recommend that you go and watch those. I went into this not really knowing anything about it, and I was really happy because the kit is super easy to build. No FPGAs, no surface mount, really easy kit. And I thought that this would be good for beginners to come in and build something and then learn how to program. I am not a beginner when it comes to programming. You may remember I did the Commodore 64 Pac-Man, and we've also got the Spectrum Next stuff. But I'm not an expert when it comes to Linux. I know enough to do Raspberry Pi stuff. It turns out that I am the first person at the time of making this video to actually try to use Windows as a development environment. So I was on my own. I literally had to work this out step by step, and that's going to be the second part of this video. I did work it out, and I have got it compiling from Windows, talking via USB serial to the new computer. So at the time of making this video, although it was an easy kit to make, the development side is still very early days, and there's still lots of things to work out. I didn't realize just how early it was that I came into this. But hopefully this video will give us a good idea of how to get Windows set up using VS Code and all the various command line tools that we need, and get it actually working so that more and more people can learn how to program. And perhaps some of you can tell me that I'm an idiot and that this would have been a better way to set the environment up. But I am the first one to try, so please excuse me. So let's get on with building a kit before we get into the real deep stuff of setting up VS Code. As we'll see on the back, there are some quite strange values. 8.06K, 4.02K, 499R. You're not going to find those in your everyday kits. My advice is order the BOM from Mouser. You just drop it in there and you've got the BOM for all of the chips and the BOM for all of the passives. Just order it all together because you could get caught out like I did. So I'm going to drink my coffee, solder in some components, and it should be nice, easy going. Everything looks quite easy and it's well laid out. And as always, we start with the components, the lowest going up to the highest. Let's get another board. I have got this board, which has got all the bits laid out in it. I printed a resistor bender. I normally just wing it. So all of the caps are 100 microfarad, except for the 247 microfarads. And it's said to order axial, but I don't have axial, so I've got some just normal ceramics. So we've got two 47 ohm. Let's get it in here. So these strange values are for the color ladder for RGB, because VGA is analog. To get the different colors, you output the same signal from the Pi, but it goes through a resistor, and each resistor slightly lowers the signal, and that's how you get your different colors. So I'm guessing that they chose the specific values to get very precise colors on the screen. And then that's 1, 2, 3, 4, 5 up. So I would be interested to build another one, because I can build two, and see what the colors look like. R10. See what the colors look like with resistors that are close enough. So that's R5. And I am going to put all of the bands facing the same way. So 499, 499, 499. Okay, that's all of those. And we've got 1K. So I do have the 1K resistors. These are not the best. It should be basically a repeating pattern for the red, the green and the blue. Okay, and then it is 2K. Let's get 3 of those. So I think the last kit that I made was the ZX0, and I've not had a good time with the ZX0. It works okay, but the reason that I brought it was to make the Spectrum Plus keyboard, and it just does not work with any Spectrum Plus keyboards. So I was chasing problems, thinking it was my design, and no, the ZX0 does some really strange stuff, even with an original Plus keyboard. Okay, and then, so that's the 2K. All right, now we've got 4.02K. So the designs that I did, where I copied the 48P KDLX or whatever it's called, and I thought that it was just no good, and it was working like keys were stuck down, and I couldn't work out what was going on because I didn't understand how the circuit was working, and people that I showed the design to kind of couldn't work out where the power was coming from. Because I didn't know where my power reference was, I was finding it hard to diagnose. And then I blew up the Pi in the ZX0, and this was at a time when it was very hard to get a Pi, so I ended up borrowing one from a 3D printer. Put it back together, borrowed the Spectrum Plus from Tristan, and then realized that the original keyboard didn't work on it. So that was fun. Right, 8.06K. I then ordered another Plus keyboard that somebody else had done, and obviously that didn't work as well. And that was when I realized, and that did work on an original Spectrum Plus. So that's been fun. The ZX0 does work okay with a basic keyboard. It was a bit awkward getting Spectrum files on there because they were all long file names. I think there's another one of these. Yeah. And it didn't like the long file names, so they all just had basically the same, like, short random text. R18. So I'm looking forward to seeing what this can do, and programming. I've been looking for like an evening programming project, And I was thinking about the Aegon Light, but because I want to wait and see what the RMC one is like, I didn't want to commit to buying one. Okay, that is all of the resistors. There we go. I am still enjoying the JBC clone, still using the same tips, still really good. And I also just brought the CNC Kitchen insert tips for the old soldering iron. I'm looking forward to using that. So I can use the push inserts for 3D printing stuff. Okay, it's not too bad, they came out okay. So now we'll do the sockets, because the other caps that I've got are going to be above the sockets. Let's put these two in first. I don't have sockets for the middle, so I'm going to use some round pin headers. Okay, now let's do the 100 microfarads. So these are just basically decoupling caps. Oh, they're going to look ugly. I thought I had some actuals left over from the Atari, but I didn't. 0.1, yeah, so it's just those two, just the 247 microfarads. So because I forgot to order the right components from Mauser, I didn't realize that there was 47 microfarad ceramic caps. I went to get them from RS, and the prices on RS, it was you had to order 10, and they were £1 something each. So I only needed 2. It's going to cost me £12, and then you had VAT and delivery on top. So it was getting up to £20 just for the capacitors, and then there was the resistors as well, because obviously the crazy resistor values. That was just insane. I ended up ordering them from Mauser again and padding the order out, but the same components from Mauser were £5 for the same amount. Convenience, man, they get you with the convenience. So you'll see that these are 47 microfarad. and they're not polarized. Okay. We've got some headers for I/O and expansion. Okay, so then that just leaves the Picos. So the Picos aren't programmed yet. Let's do this one, but they need to go on these headers. So again, it's best to put them in the headers so that you know that everything's straight when you solder it. And they'll pretty much stay in place. Look, there's a bit of tension on there. We'll tack up the corners. Did you all watch the video by Control.Reese on the joystick? He really likes it. So I am going to be moving forward on that, and just a few minor details to do. He asked to have the position like paddle or joystick on the case so that it was clear what position does what. So I'm working on that. And the buttons so that they're a bit nicer to use, because I didn't quite like them, but Reese said that they were okay. And I've ordered some cheapo Atari leads from AliExpress that have got proper strain relief on the end. And I think my goal is just to have kits on my store with the parts, and then you can buy the files, but it'll only be like a couple of £. So you can make your own. And if people want me to make one for them, we could do that. Okay. That's it. It is made. We've got some 3D printed PCB standoffs. Just to get it off the floor, well, off the bench. Oops. Oops. And we'll obviously 3D print some kind of case for it. I wonder if, because I'm guessing that this is going to use a USB keyboard, but could we use the GPIO and use some kind of retro keyboard or the Mectrum keyboard? So there we go, that's on feet. we can put our chips in. So another thing, hang on, it's coffee time. Another thing that I was looking forward to was using old parts. I thought that this might use original processors. So that I could use some that were on, that I've got spare from a faulty Commodore hard drive. But it only uses new ones, no CMOS parts. And like I say, I do have 2 of everything, so I could well make another kit and maybe offer it up in the charity fund with more fun making it. Even though he'll hate me for doing that because I've already given up a Mectrum. So these are the logic chips, 74ACOO, 74ACOO. And again, I ordered these from Mouser instead of trying to find them on eBay and other places. The processor, the RAM, and I think it's like a programmable I/O chip, all from Mouser as well. So that's the top one. HC30E, that's the bottom one. Okay, that's it. Pico 6502 computer. All that's left to do is program the firmware. So we'll come back in a second. We are back, and I've programmed the Picos. It was very easy. You just plug it in with the boot select held down, and you copied the firmware across. As simple as that. It's really, really easy to program a Pico. There's 2 files, there's the VGA and the input-output. And then you plug them back in, and I've done a quick check. There's no issues with the board. I can't see any short circuits. We've got a Raspberry Pi keyboard connected up to the trusty VGA monitor, and plugged into a USB charger. So let's turn it on. It'd be nice if it had a power switch. So I'm just going to have to plug in the USB lead. Both the lights come on the Pi, and we've got a screen. It says Pico Computer 6502, 64K RAM, 64K XRAM, 16-bit color VGA. I had a quick look, and it says if you type help. So the keyboard is working, and we have a list of commands. So help, this help about includes credits, status. I have no idea. Show all settings in USB devices. No idea what any of that means, but it says we have one HID keyboard, and one other reports. ls. No. So we need a USB device connected to load and save files, but that's okay because the Pi keyboard has got a USB hub on there. So I guess until I've got that bit sorted out, that's all we can really do. But it's working. So I think that's great. That's good enough for this part of the video. So we've built the Pico computer and that was easy. But I've now found out that this is so new that I am literally the first person that has tried to use this with Windows. Everything was initially set up for Linux. I am not a Linux person. I can just get by, but when things don't work, I don't know enough. And I'm more comfortable in Windows. I do have experience with VS Code, and we are eventually going to be programming with CC65. And if you remember, I did this with the Commodore 64. So again, I have some experience with that. So we are going to be setting up a development environment in VS Code. We do have a lot of tools that we need to install and make sure that they are working in the background. And we have to set up the paths and various things like that. So I spent a couple of days with the help of the Gouldfish. Go and check out his channel, and also Rumble Thumps. And we've eventually got to the point where I am able to compile a program from VS Code, upload it to the Pico computer. So what I've created is a VM. I've got a virtual machine with a clean install of Windows 10. And we're going to go through the steps, and I could struggle along the way, but I do have a working system that I can use as reference. So I think step one is to install VS Code, just because that could need a lot of Windows updates and things like that. And then once we've got VS Code installed, we'll install the compilers and all the other stuff that we need and set the paths up. So let's get on with that. Before we do anything, let's just get rid of that Microsoft Edge logo. So like I said, this is a fresh install of Windows 10. So I don't know what version it is. I just got an ISO off Microsoft. So I'm guessing it's reasonably new. Yeah, blah, 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 cookies, reject all. Windows installer x64. Reject. Oh, so yeah, this. I really don't like this new downloader thing where the downloader shows up in the top of the screen rather than the bottom. Don't like it. I don't like it. So just next, install basic installation. Okay, so I'm not going to do anything else. I'm just going to leave that as it is. And that was good. Didn't complain about anything. It didn't need any updates. So next, I'm going to install Python. And I found the best way to do this was from a command prompt. And I just typed Python and it launched me to the store. This was fairly straightforward as well, nothing too difficult. Again, I'm not a Python user, so this is, don't ask me questions. I literally know enough to get this working. Okay, so I think that is done. So if we go, let's just close that. Go back to command prompt. Okay, so on my version, it installed Python and it wouldn't work with the command Python. I had to type Python 3.11, so I need to remember that. So we need to install pip. Go away. This is the one, okay. So verify that Python is installed. It is installed. So we do this command, which downloads that script. Then we can install it. Okay, so that is pip installed. Inside Python, we need to install PYserial, which is a tool for uploading to the Pico. Python-m pip install PYserial. Okay, so that is installed. So that was Python and pip and PYserial, and that's all we need inside Python at this time. So next we've got the various compilers and things. So CC65. That is installing, and then we need msys ys2. Get that msys ys2. Let's go down to the latest package and we'll download that. We want Cmake. Latest release, Windows. ASS. For the Python uploader and to make the basic program, we need this 64 TAS. Okay, so now if we go to our downloads, and I think that's everything we need at this time. So let's close all of that. Oh yeah. So from this PC local disk, I'm going to make a folder called Pico 6502, and that's where I'm going to put my projects. Okay, so on the Pico GitHub repository, we need to go to this VScode section. It says to create a new repository, but we'll need to sign in. I'm just going to download it. And then we also need the SDK. Okay, so downloads. We go to our 6502 VScode main. I'm going to copy all of this. Go to our Pico 6502 and paste. So that's our project file. Then if we go to our SDK, we want all of these files copied over to there. So that's our basic project. and these are the include files. So now let's install some of these programs. So 64TAS is just a folder. So right click, extract all, then we can put the name where we want to extract to. I do a stupid thing and forget that there's a folder inside here, so it extracted the folder to the path that I specified and I have to rename it. 64TAS goes into the root folder. So 64TAS is in the root folder. Then CC65. Okay. Then we can install Cmake. I'll add it for all users. And again, I'm going to install it in root directory. And then msys2. And that installs in the root directory anyway. So that's all of those. So now let's go back to, so we've got 64TAS, CC65, Cmake, and msys64. Device manager. So eventually we'll see a port that will show up just there that we need to use. So control panel. Change that to small icons, and we go to system. We scroll down and we go to advanced system settings, environmental variables, path. Then we click edit, click on new, and then we can type in a new folder that we want to add to the system path. I did it a bit rubbish, as you can see. You don't really need to click OK. You can just click on another one and keep editing. /64TASS. I'm sure there's a quicker way to do this. C /MSYS64/MINGW64/bin. So I'm copying this from the one that's working. So MSYS64 bin 64TAS. So there's one more program that we need. Which is called Make. I don't know if this is the right one. Again, I'm putting that. I don't care what it says. I'm putting it in the root directory. Okay. So let's go to a command prompt. Cmake, you can find it. CL65, no input files. Make path, edit, new. Okay, so all of those programs are now available on the path. So let's go back to VScode. Okay, so now if we go to here, extensions. We need to install some extensions on here as well. Cmake tools. So just because we've installed the program, we need to install it as an extension inside Visual Studio, VScode or whatever it's called. We need to install CC65. Okay, and it does say that we must not install IntelliSense. So now let's go and get rid of all of these. If you go to our extensions on CC65 extension settings, we've got path to the CC65 binary files, C:// CC65 bin. Okay. Cmake tools, extension settings. I'll have to go and reference the other one. So close that, close that. So now if we go to open, we want to open a folder which is on our C drive. And it's the Pico folder. So now we have to do a few things. So yes, we want to trust it. Do we want to install the recommended extensions? Yes. Let's just do a quick test on this. So if we do Shift-Control-B. Okay, so we need, get rid of that, get rid of that, Shift-Control-P. Select kit, and then we can choose the Pico kit. And here's where the fun begins. Hello, Future Lee, butting in because past Lee kind of stopped talking for a bit. So I thought I would bypass all of his fumbling and let's just show you the final parts that we need to have in the settings. So in our main project folder, we don't really need to do anything. The Cmake just is okay. And we need to go into the VS Code section. So in here on Cmake kits, I've got the path to the Cmake file inside the Pico 6502 SDK folder. We don't need anything on extensions. In settings, we need to add this line at the top, and I'll put it in the description. Cmake.configuration environment cc65_home with the path to cc65 c:/cc65. That basically tells the compiler where all of the include files are. And that was one of the big problems. And then the default system include path stays as it should, user share cc65 include. In the tasks.json, it was just adding the -d and the COM port depending on where the Pico is connected. If we go into the SDK folder, there is the Cmake list here, and that needs to be the default user share cc65 include. We fixed that by adding the home folder. And then in the rp6502.py, it was under the argument -d, and we set the default to COM3 or whatever your COM port is. The last part is just making sure in the Cmake tools, under the extension settings, and I added under the additional compiler search directories the folder for msys64, and then I also put the additional kits, the folder for the Pico SDK. So they're all the changes that I made that got this thing working. So let's go back to pastly, where we do a successful compile and upload it to the Pico.
One eternity later.
I've worked out how to do the Pico COM port in VM machine. So with the Pico plugged in, if we go into settings, USB, rather than try to add the serial port, we need to add the Pico. So if we just click on plus and choose the Raspberry Pi Pico probe and click OK, and then we start our VM. So now we've still got the actual VGA output. Let's just reset that. And then in here, we go to PuTTY and serial. If we look on our device manager, you'll see that there is now a Pico probe and that we have a COM port 3, which is a USB serial device. So from here we could choose serial, COM port 3, open. So we've got our PuTTY line, and as I type on PuTTY, it's sending the key commands over to the Pico computer, which you can see on the screen capture. So let's exit out of PuTTY, load up VS Code. If we go back to our rp6502.py, and I changed the default device to 3, COM3 and COM3, and then if we go to tasks.json, I've set that to COM port 3. So if we go back to here, Control-Shift build, you'll see that it's executed the code, it's run it, automatically downloaded, and there you can see that the program has been run and we've got hello world. Again, if I go back to our source and the hello C, change that to hello people, save, build, and hello people. So that is successful. We have got a full environment set up in the virtual machine. So that was a couple of days of head scratching condensed down after I'd done it a few times and then reproduced it on the VM code. We really have to thank the Gouldfish, who helped me in the beginning to understand things that weren't working and point me in the right direction. Thank you so much for all of the help. You really did help to make the project work in the end, and I can't thank you enough. So I am set up, we are good to go, and I guess the next thing for me to do is learn how to program it. You will find links in the description to all of the information that you might want about this project, and keep a lookout for another part once I've learnt more about it and written something that I have to show. But hopefully more people will pick this up and it will get out into good hands. Like I say, the actual kit is really great, super easy to build, easy to find parts, no SMD soldering, it's just so easy to make. Perhaps the only tricky bit is some of the resistor values, but if you just order the BOM from Mouser, it takes all the pain away from it. So I'll see you soon on the next video.